So, hello everyone. We are now discussing about. I am telling about seminar about our moments topics in ptsp. So, this is the title slide. Introduction to probability. First, we want to know about probability. That probability is introduced through the concepts of sets. It related to the concepts of sets and frequencies, a process within uncertainty outcomes and samples. Sample space. A sample space is a number of outcomes. It is represented as sample space. Now, fundamental of axioms of probability. There are three axioms of probability. Non-negative axioms of probability. The probability of an event is a non-negative real number. The probability of event is always non-negative, is a real number. Normalization. The probability of entire sample space is 1. Additive. For an sequence of adjacent events, probability of their union is sum of individual probability. So with this we can represent it as fundamental axioms of probability. Okay. Next, there are importantly three axioms are there. They are defining random variables. Defining random variable. A random variable is whose value is numerical outcomes. A random variable is it gives numerical value to all events. Types of random variable. Discrete random variable. Discrete random variable is nothing but a finite numbers is called discrete. Continuous is taken is a given range. Continuous is nothing but in a given range we can tell the values. Discrete is individual values is finite. Expectation. The first moment we can discuss about first moment. Our topic is out because our topic is about moment. First moment is expected value. The expected value or mean of a random variable is a long run average value repetition of experiment representation. So within it is considered as the first moment which means we consider this is the definition. The expectation value or mean of a random variable is the long run average value of a repetition experiment. It is a long run average value. It is whole sum of average value we can take as expected value or mean. It is called expected value or mean. So what is a moment? First we want to know what is a moment. Is called in this ptsp subject a quantitative measure of shape. Measure of a shape. It tells about the shape in graphs and 3D. In advanced it can be 3D structures also. Now we will represent it in some graph type bell type structure. A moment of quantity measure shapes set of points of probability distribution. The concepts of analogs up to the moment in physics which describe the distribution and static moment summarizes various descriptive static measures. With this we can conclude that we know that what is moments. The moment is a quantitative measure of shape. We can consider that it is an tells about shapes of the given probability distribution. Types of moments. We can classify moments in about origins and raw moments calculated with respect to zero. Central moment. Moments about mean moment calculated with respect to the mean of the distribution. These are more commonly used in discrete the shape. Moments about the origin. Calculating raw moments. RTH moment about the origin of random variable x is defined as expected value of xr. Formula for continuous random variable. This was formula. I can this was formula. Now in this we can say that this got some mistake here. Okay. This. Now this is the formula of continuous random variable formula. In this x is sorry. X is in the limits of a and b. It is integral of b of f of dx of x dx. In this we can compute which is the formula of moments. Okay. The first moment about the origin is mu. Central moments. Now next topic is central moments. Understanding the shape and distribution. Central moments are describe the shape of the probability distribution. Central moments are actually describe the shape and probability of relative to its mean. The RTH central moment is defined expected values. You here x minus mu into r, it is defined as that. So in the previous weekend we saw that continuous random variable formula that is applied here. The first central moment is always 0. First central moment, now we can say the first central moment is always kept 0. The first central moment is always 0. This is because of deviation from mean also cancel each other. This is the reason that each mean always cancel to each other. This is the reason of first always 0. Second central moment variance. Second central moment is called variance. Measuring spread. This is called central moment for r equal to 2 is variance 6. It is described as spread depression of observation of around the mean. Large variance indicates the data point of the further from the mean. The sequence of roots variance is standard deviation. The square root of the variance is the standard deviation. If we do the square root of the variance, we can get directly the standard deviation. The large variance indicates the data points of further from the mean. With this, we can conclude the definition of second central moment called variance. Third central moments are skewness. Skewness, it is also an important topic. Measuring asymmetry. The third central moment for r equal to 3 is used to define skewness. Third R3 this third central moment is denoted by R3. We can directly tell R3. Skewness described from the sample space differ from symmetry distribution. Skewness equal to 0. The symmetry of distribution like a normal distribution. If the skewness equal to 0, then symmetry of distribution like a normal distribution. Skewness. If skewness is greater than 0, it is right skewness. It is little bit rightly skewness. We can see tail is on the right side. Tail is on the right side. If this is the graph, if skewness, this is the right. If skewness, it is the right. If more than 0, we can get graph like this. If the skewness is left side, you can get a graph like this. Tail is on left side. This is the skewness left side and right side. If the skewness is greater than 0, it is on right skew, the tail is on right side. If the skewness is less than 0, then it is left side skewed, left skewed. Higher order movements. Kurtosis. The fourth movement is central movement. For the fourth central movement is used to define kurtosis. Kurtosis is a measure the tidalness of the probability distribution. It is described whether the distribution tails are heavy or light or related to normal distribution. Movements generating function mg by MGF, a tool of finding moments. It is a tool used to find the moments. The moments are moment generating function of random variable x. It is function derivative 0 yield moment. It is a function that finds the moments of the function. It provides the alternative way to complete moments without using definition expected to value directly. Next one, characteristic function. Another powerful tool in this concept is the characteristic function is closely related to the MGF. We previously discussed this moment generating function. It is closely linked with characteristic function. It is also used to analyze the random variables. Now, previous one is used to find. This one is used to analyze. It is also exists random variable unlike MGF, which may not exist in some distribution. We have some limitations in this. MGF is you can clearly see MGF is not exist in some distribution function. MGF not exist means we compulsory use this characteristics function. That's why this is used. Joint movement meant by multiple random variables. The concept of movement can be extended multiple variables to describe their relationship. The concept movement can be extended multiple random variables. It can be extended to multiple random joint variables. Joint movements are extended to more multiple random variables to describe their relationship. Joint movement origin describes the correlation of another relation between variables. It tells relations between the multiple random variable, and joint center movement describes those relations with respect to their mean and important examples of covariance. With this, we can conclude that how these movements are useful to our ECE department. Signal why movements matter in engineering in our ECE group. Signal processing. It is used in signal processing and characterize random signals. The mean can be represented as DC component and variance of power. It is used in mainly signal processing and DC component and AC components. It is used in both. In communication system, we can use it as statical properties and noise calculator designing. Statical properties and noise calculator designing and robust systems movements help to calculate different types of noises. With this we can use movements can be used as several types of characterize different types of noises. It is also used in image processing. Static movement are used to texture and analyze about the recognition. Now, summary. In this seminar we all learned about movements, fundamental reception probability and distribution of a shape. Movements about the origin and first three central movements, mean, variance and skewness. We can learn movement have critical applications also we learned. So that's all for today. Thank you all.